the announcement of our next speech at least. That's quantum computing enablement for the German industry, the Fraunhofer Quantum Computing Competence Network. And that's our partner speech today. And the Fraunhofer Quantum Computing Competence Network aims to advance the key technology of quantum computing in Germany. And how that is done, Professor Manfred Hauswirth, spokesman of the network and executive director at Fraunhofer Focus, the Fraunhofer Open Communication Systems, will explain. The floor is yours. Manfred, are you there?
I'm here. Thank you very much. I hope everybody can hear me. And thanks for having me here in this very prestigious event. I'm happy to start the presentation of the competence network of that Fraunhofer has set up for quantum computing and enablement of industry in the last 18 months. So how does this competence network look structure-wise? Well, you know, or you probably know if you have worked with Fraunhofer, we are organized in institutes, a total of 26,000 researchers. And we have competence in the area of quantum computing spread all over the country. So we decided to set up this network also along the competences of these institutes. The idea is to have regional centers, each of which with a specific expertise and background as a local entry point, but having access to all the expertise of the whole competence network. The idea was to have a very easily accessible entry point into expertise for quantum computing, both for education, but also for R&D, specifically targeting German industry. The expertise of the institutes is along a wide range of application domains. Most of them, I would say all of them, are also mentioned in the current course of the German Ministry of Science and Education. So it's logistics, chemical and pharmaceutical industry, financial and energy sector, material sciences, and of course, IT and IT security technologies. Essentially all the areas that have hard to crack problems where we know the progress which we can make with traditional high-performance computing and traditional algorithms is limited. And this is where quantum computing really comes to the rescue and enters the scene, and where quantum computing becomes very, very interesting. As Ina Schieferdecker from the ministry has already mentioned, we also try to support the education by multi-level training programs and continuing education for industry, but also from a very low level up to the highest levels of expertise. And if R&D departments, industry or academia has specific questions, we also offer expert consultation. The core part of this quantum competence network, besides the people skills and the expertise in hardware and software, is an IBM Q System 1 installed in Enian near Stuttgart in Baden-Württemberg. Now, to put some names next to the regional centers, here you have a list of people. If you have worked with Fraunhofer, you probably know them already. Again, let me repeat, the idea is local access point, but entry to the whole area, to the whole network of expertise in these competence networks. We try to make it as easy as possible for universities, for R&D departments, for companies to enter the quantum computing market, both on the hardware, but also on the software side. Now, what is on the plate regarding the hardware? IBM has installed a Q System 1 in Eningen. Here on the left side, you have the technical facts, so 27 superconducting qubits, quantum volume, it's a measure how powerful a quantum computer is, of 32, very good coherence time, very low single gate errors, etc., etc. It's operational since January of this year. And additionally to this access to the system here in Germany, the competence network of Fraunhofer also offers cloud access to the IBM quantum computers in New York. Now, the important key facts on the right side, this system is available exclusively for Fraunhofer and partners. It's operated entirely under German law, which means data resides in Germany and GDPR applies, and it's one of the most powerful systems currently available. We offer this both for academia, but also, of course, for industry. And industry is as much a target as is academia. Specifically, the legal construction of this system may be very interesting for industry. I will come to back to that a little bit later when I talk about the organizational aspects. Now, how can one get access to that? I mean, the system is open for projects with Fraunhofer, which of course we would highly welcome, but of course also for projects without Fraunhofer and for strictly internal research projects, for universities and publicly funded R&D facilities like Fraunhofer, Helmholtz, Max Planck, the universities. We offer monthly tickets at the price of 9,077 euros, which means at the moment you have 100% of the platform available. The more interest we generate in this platform, we need to move to a fair share model. But at the moment, the situation still looks very good, and our partners who are on board already are very happy because they get a lot of computing power at a very reasonable price. We did a review on the pricing, and to my knowledge, this is currently the best and cheapest offer worldwide. For industry, it has to be a little bit more expensive, but it's not about Fraunhofer wanting to earn money, but rather about the different regulations in terms of accessing to a computer that's funded by public money. If you're interested, please feel free to contact the desk for the Competence Network. You have the email address on this slide and also the link to the website. The network is available to all companies with headquarters in Germany. Now, you see a lot of legalese here, like access and license agreement, member compliance declaration. Well, it's cutting-edge technology, which also is monitored by a lot of security regulations, which means there is quite a bit of analysis which needs to be done before the contract can be signed to ensure that we meet export control requirements of the United States. Now, don't be frightened by the size of the contract. We wanted to have an airtight contract which ensures that the data of the people who use and the know-how of the people who use the quantum computer are protected in the best possible way according to industry standards, as you know from other platforms like cloud platforms or other software platforms. Now, a little bit more on the legal framework, because we see that this is actually the central cornerstone of this infrastructure. You know, why is it so important that we have a system here in Germany, and why is it so important that it operates under German law? But essentially, in a nutshell, it means the IBM Q system, one in Ehningen, is the only system worldwide where GDPR applies to 100% for a professional, for a industrial scale quantum computer. Additionally, all the data, all the security information, all the logon information, anything, all the metadata that you need to access the quantum computer remain here in Germany. The Fraunhofer Society is the exclusive gatekeeper for this access to the IBM Q hardware. You can run a very wide range of applications on this hardware. The only thing that's excluded is we are not allowed to do military research on the quantum computer. We've also negotiated very favorable IP regulations with IBM. Essentially, it means that the creator always owns what he or she generated using the quantum computer. This applies to software applications and algorithms. It's even further that we are not even required to inform IBM themselves whether we have generated IP. The only requirement IBM has, and this is perfectly understandable, is that we are not allowed to exclude them from their own platform with new patents, which is fair enough in an industrial setting, in my opinion. Now, I would like to finish with a little bit of perspective why it is interesting to go on this infrastructure. Now, is quantum computing the new silver bullet? Well, yes and no. The important thing is it's not a question if quantum computing will enter the market soon, it's just a question when. And then it is extremely important that both from an academic side, in terms of the people we educate, but even more so from an industrial side, we have the people ready and we have the know-how ready. So it is like very often in computer science and software systems, there's a lot of pre-work to be done. And when the last piece falls into place, there's a phase transition, and then boom, the market goes off. So what is currently possible and what isn't currently possible? Well, quantum advantage has not been shown yet, but it will be shown. What you have heard in the news are very specific problems that are very limited practical relevance. But we are already working at a lot of practical problems. And when the puzzle pieces fall in place and these problems will be solvable, then there will be a lot of possibilities for industry, for services and patents. But the important thing is, and this is also what we communicate in any direction as Fraunhofer, do not overpromise. We're getting there. We just cannot say how fast it will be. Well, will quantum advantage be shown in 1, 2, 5 years? We don't know. We already run first applications with high potential on the quantum computer. And from our point of view, quantum is an accelerator for computing, for supercomputing. Now, it will not replace supercomputers, but it will make some very hard, algorithmically very hard sub-problems much faster. So why should you be interested in accessing a quantum computer now? It's a little bit like learning to drive. It's a completely new car, and it's a car that isn't similar to any other car. My background is a computer scientist. I educate a lot of students. Actually, all computer science students at TU Berlin have to go through my course in computing. But with that knowledge, you do not know how to program a quantum computer. You need a lot of knowledge and know-how from physics, from computer science, from electrotechnical engineering, sometimes from material sciences, and of course, mathematics, specifically simulation and optimization. And you need to build up these skills now. When the quantum computer is ready, the labor market will be dry. We are already seeing first signs of that. It's already getting hard for R&D institutions like Fraunhofer to find the right people. So it's important to do it now. You have to understand what is possible. You have to build up the skills in your own company, and you need to build up the competences when the quantum advantage comes actually to fruition. And I would like to wrap up with a simple picture how we see quantum computing in the orchestra of other new and novel computing paradigms like neuromorphic computing or domain-specific and general-purpose computing. In our vision, the optimum is like you have an application-related problem in any area. You have the data, you create the data and the models, and then you inject it into a trusted infrastructure that decides which kind of technology, which algorithm can, or which combination of technologies and algorithms can solve your problem best. It's probably an iterative process that has to go in a couple of circles until you will find the optimal composition and the optimal algorithms, but the solution will come out in the end. And you see here quantum computing as one of the building blocks, an essential building block, but not the only one. Don't throw away any traditional hardware yet. With this, I would like to finish, and if there are any questions, I'm happy take them, and I hope I can answer them.
Well, thank you very much, Manfred. A very interesting overview. We don't have audience questions, but I do see I do have a couple since we have 2 more minutes left. When you talk about the network, you talk about German law and regulation. What are, especially looking at that, obstacles or maybe better phrased challenges in your daily work there?
Well, it is important for companies when we set up this network to be safe on a legal side. The American and the European legal system are very, very different in terms of the requirement. For example, in terms of privacy, GDPR. All of the companies, I guess, in the call know about the issues about GDPR, and also whether, and this was a long discussion in the negotiations regarding the legal framework, how much access the American government can have while the computer is still in Germany. Now, I'm not a lawyer, but I can tell you that the Fraunhofer lawyers and the IBM lawyers came up with a solution which is really protecting European companies, which is protecting their IP and which is protecting the data. And this is what makes it so unique. So to put it a little bit bluntly, everybody can buy a quantum computer from IBM, but the legal framework is actually, besides the expertise that we offer, the scientific expertise, that is actually really unique. And this is something which will simplify the creation of IP, of software and hardware significantly for German and European companies.
Concluding question: what can we learn from like the giant platform companies on the US side or on the Chinese side, on the one hand, and maybe on the other hand from startups? Anything that you would like to mention?
Well, the important thing in new technologies, it's a marathon. Don't expect a quick thing. And that is what the US companies, and I'm sorry to say so, still do a bit better than the European companies. We see this in platforms. So take cloud computing. Well, a lot of the technology was developed in Europe. It was called grid computing. It was very well funded by national and EU programs. And at some point, the Commission and the public funders said, okay, now make money with it. We weren't very successful in Europe. I don't want to discuss the reasons, but essentially when cloud computing came, the only difference between grid and cloud computing is you take a grid computer, you combine it with a business model, and you have cloud computing. And of course, this also means taking a bit of risk. And sometimes the risk is not low, but we have to get out of this corner from thinking that incremental development will sustain our wealth and our industrial and scientific development for a long time. At the beginning, it's also necessary to take risk. It's necessary that public funders take risks, but it's also and very much necessary that industry takes some risks and bets on technologies. And again, the revenue will not come tomorrow, but the day after tomorrow.
Well, thank you very much, Professor Manfred Holzwirth, and you'll stay with us and be available at the Meet the Speakers area. Well, you're taking the risk here, but I guess that's a very worthwhile risk, and discuss with our audience further questions. Thank you very much.